Do you see whiteboard or no? No?
No.
No?
Yes.
No, sir.
Yes.
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 Yes. Maybe you have delay, no?
No, I didn't see it.
Yes or no?
No,
Yes.
No.
Oh, now I see it.
I can
No.
see it.
Okay.
We see it.
Don't worry. Try. I.
That is the whiteboard. It's just the PDF is in there.
Yeah. So I put on the whiteboard the PDF.
No, it's the only thing I see is you between the trees.
Okay.
I think you just have to change your view. That's what I did.
Yeah, I did.
No, I'm just telling her.
Do you see now the whiteboard?
I see it.
Yes.
No.
No.
Well, to say the only possibility is you go out, and when you get inside again, maybe you see the whiteboard.
Yeah, I'm gonna do that.
Okay. Sometimes some computer have delayed. Guy, to take that class, you need good computer and a strong internet connection. So you have no this, you cannot take this class.
You just need to change the view to speaker view, and it shows it.
You go out and you come back in again. You
Exactly. You go out, and when you get in again, you see the whiteboard, I suppose. Okay, no more delayed. Question 1. For a polynomial listing each real zero and its multiplicity, determine whether the graph crosses touches and the x-axis and the x-intercept. Okay, the first question is question 1.
Professor.
Diga usted.
Okay, now I'm seeing. Okay.
Sometimes happen there are some delayed, so you need to wait, depending on your internet connection and your computer. Okay, entonces what should I do? Focusing. I need to determine the zeros of this polynomial. Super easy because you put equal to 0. 1/3 x to the 4th power x squared minus 5 equal to 0. And the only guy gets possible to be 0 is this part, x to the 4th power equal to 0, or x to the 2nd power minus 5 equal to 0. Now it's obvious x equals 0, pero 4 times multiplicity is 4. That means that we have this, so the degree of this polynomial is 6. It's obvious, right? 4 and 2. So you FOIL this, you multiply, distribute it. The higher exponent is 6. And so we have in total 6, 0. In this case, 0 4 times multiplicity is the name of this. And the second is quadratic equation. I move 5 to the other side, apply square root, plus or minus radical 5. In conclusion, we have 6, 0. They are 0, 0, 0, 0, 4 times multiplicity 4. And 2 is radical 5 positive and radical 5 negative. I know that when the multiplicity is even, so you need to know that when the multiplicity is even, gets 4, the graph touch the x-axis. So actually, this is 0. Suppose that this is radical 5 positive and this is radical 5 negative. Our graph look like that. Cross, touch, cross. So we have this x-intercept cross. How do you know que cross? Because multiplicity is 1. Multiplicity is 1. Multiplicity is 1. This touch, because multiplicity is 4. When the multiplicity is even number, touch. And multiplicity again is 1, cross. And the aim behavior of this polynomial is obvious, que look like that. Look. Because it's degree 6. Even. And the coefficient is positive. Que es 1/3. This is the aim behavior. This matching perfect. Any question? Entonces, what option I select? I select option B. Option B, say 0 multiplicity 4, touch, x-axis. Radical 5 multiplicity 1, cross it, x-axis. Negative radical 5 multiplicity 1, cross it, x-axis. Do you understand or no? Come on, guys. This is the review. You need to understand very well 100%. We move it all again over each topic we covered in the last lecture. But it's important for me that you understand very, very, very well. Any question?
And
I don't hear anything, mister. Speak slowly and put the microphone loudly.
sorry, I was saying I understand. I'm on my phone right now because my internet's being very in and out.
Okay, super. Any other question? No? Let's move on to number 2 question. May I erase the board or no?
You can erase the board, Professor.
Yes.
Excellent. Okay, number 2. Number 2, the polynomial is f of x is equal 1/2 x to the 4th power, x to the 2nd power, minus 5, x minus 2. Well. I see that the degree of this polynomial is 7, no? Because degree is 7, because 4 plus 2 plus 1, no? This is 1. It's 7. Entonces the aim behavior and the coefficient is positive. I suppose that the aim behavior look like that. Okay, it's right up, left down. But the question is not like that. The question is the intercept, so the zero, real zero. So you put equal to 0. You put this expression equal to 0. And I realize that x to the 4th power is 0 is my first equation, or my second equation is x squared minus 5. And my third equation is x minus 2. Actually, we have one equation, degree 4. Actually, it's 0. Multiplicity 4. And remember, when the multiplicity is even, touch. In this case, similar is x squared equal 5, square root both sides, plus or minus radical 5. Actually, we have 2 solutions, but the multiplicity is 1 and no cross. Cross what? X-axis. We are talking about x-axis. X-axis. And we have linear equation. X equal to, again, multiplicity 1, cross. X-axis. X-axis. The conclusion is we have 7 zeros. X equals 0, multiplicity 4, touch. X equal radical 5, multiplicity 1, cross. X equal minus radical 5, multiplicity 1, cross. And x equal 2, multiplicity 1, cross. Entonces, our graph, no necessarily they say the graph, do the graph, no. I using my imagination, our graph look like that. Let me show you. This is 0. This is 2. 1, 2. This is radical 5. Radical 5 is approximately here 2 point something. And negative radical 5 here. And the end behavior is like that. Look. Touch, cross, and cross. Any question?
No.
No.
Super.
Super. Okay, minimum question you have, let me know. Because this is a review. This is the moment that you clarify your ideas. And to be ready for the test, no? Okay, let's move on to the question 3, it's completely different. Is do the graph of the rational function. Now remember the several steps that we need to apply. Erase the board or no?
Professor, so what would be the answer for number 2?
The answer for number 2, miss, is, let me see. Let me see, multiplicity 4, 2, multiplicity, I suppose que es C. Are you agree or disagree? No, Toshi, yeah. I suppose que sí. Makes sense, que sí?
Yes.
Professor,
Yeah, go ahead.
one quick question before we move on. So
Second?
I have one quick question before we move on. Whether the graph touches or crosses is dependent on whether the multiplicity is even or odd?
Absolutely, absolutely. The rule is, si the multiplicity, mister, is even number, the graph touch. Si the multiplicity is odd number, the graph cross. Okay, look here. The only guy gets even is 4. It's in 0 touch. And it's cross, cross, and cross.
I see. Yeah, it makes sense.
Super. Another question, guys. We have 2 lectures to cover this package. So and also I will send also the solution of this. I have in another video. So you have plenty information to prepare for the test. Okay, let's move on to the question 3. Now question 3 is easy. Is a rational function. Do the graph of the rational function. So f of x is equal x minus 1 over x. Well, it's a rational function. So you put it in that way, you condensing only one common denominator is x squared minus 1. And you can see clear the degree of the polynomial. Remember, the definition of the rational function is the division to polynomial. The polynomial in the top degree is 2. And the polynomial in the bottom, the degree is 1. Now, remember the 7th step to do the graph of any arbitrary rational function. The first one is factor 4. Factor 4. You write factor 4. And factor 4 is, this is factorization, this is x plus 1, x minus 1, because actually this is the difference of a square divided by x. Okay, we have no common factor to cancel out, therefore my graph have no hole. No hole. Remember, we have hole when the one factor is cancelled. In this case, no. No hole. Number 2 is find the y-intercept. Y-intercept, the formula is evaluate 0. Evaluate 0 where? In the original or in the factor form? Either way. Let's do it in the original. Well, the original is, wow, is 0 squared minus 1 divided by 0. It's only 5. Therefore, we have no y-intercept. X-intercept. Well, the function equal to 0. That's the formula. This is the formula always for finding y-intercept. And this is the formula always for finding y-intercept. Okay, it's easy because it's a rational. So you take the top part equals 0. Because f of x, you know, is equal p of x divided by q of x. So you want to investigate equal to 0 is because p of x is 0. Yeah, I don't care q. And you focus it in order to find x-intercept and the polynomial on the top. Polynomial at the top, you take in the regular way or in the factorial form. Either way. I prefer in this case, I don't know why, factorial form. And you discover okay, x plus 1 is 0 or x minus 1 is 0. Therefore, negative 1 and positive 1. And we have two. We have two intercept. Negative 1, 0 and 1, 0 because the supposition was, remember, okay, y is 0. This is y, valid. So far, we have no y-intercept and we have two x-intercept. So far, everyone follow me?
Yes.
Let's move on to number 4 step. This is classic, guys. This is 7 step. Okay, it's playing in the lecture, and you are doing step by step. Always, any students. What is the next step? Baric acid. What is the formula for finding baric acid? You take the polynomial on the bottom. Remember, we have one more time. F of x in general is p of x divided by q of x. For finding the baric acid, you take q of x equal to 0. So the polynomial stay alive in the bottom equal to 0 represent the baric acid. It's obvious in the factorization we cannot cancel out anything. This is just x equals 0. X equals 0 is our baric acid. And so this is a moment in which I want to do the picture. The picture is, so far we have no y-intercept, no, nothing. We have two in negative 1 and in positive 1. Okay. And baric acid here. And 0. Baric acid. It's the only thing we have so far. And number 5 step. And number 5 step. You determine the horizontal acid or slag acid. And that depending of the analysis of the degree we are doing. Okay, we go back at the beginning. Look, at the beginning, we have that function, okay, that function is f of x equal x squared minus 1 divided by x. Degree is 2. Degree is 1. And you need to know by memory, when this situation happens, when the degree of the numerator is greater than 1, no more than 1, 1. So A1 and 2 or 2 and 3, 1, we have a slag acid. And we have no horizontal. No horizontal slag. And makes sense because before, to condense in this fraction only 1, at the beginning we have x minus 1 over x. It's the original problem. And this represent, this part represent the slag acid. Is the line y equal x. And the line y equal x look like that. Okay, What is the step 6? Everyone follow me, guy? Sure? No problem?
Yeah, I'm following.
Okay, the step 6 is symmetric. Symmetry, you know, you replace x for negative x. And let's see what happens. This is my original f of x. Okay, it's x minus 1 over x. Now you replace. This is negative x plus 1 over x. You see, wow, they are completely opposite sign. Therefore, this is odd function. See, as odd function, I take advantage this symmetry. Because the symmetry will respect the origin. And when you pick a number 7, the typical point, then we take advantage. For example, I pick here. I focus again in the roughly sketch. This. You pick, for example, 2. It's an arbitrary point. And number 7 is additional point. How many points? Well, 1 here, 2. 1 point here is 1/2. In between 0 and the x in a set. Maybe, yeah, it's enough. 2 is enough because when you evaluate n2, the answer in -2 is the same value, but the opposite sign because it's odd function. So you, for example, so you plug in 2 in the original equation. The original function is x minus 1 over x, no? It's 2 minus 1/2. Okay, it's 1.5. The point is the point. Let me write here. It's the point. It's the point 2, 1.5. I know that when it's -2, it's -1.5. Makes sense, right? I take advantage of the symmetry, it's odd function. When you change x for negative x, the y change also. And f in half is 1/2 gets x. Minus reciprocal 1/2 gets 2 is -3/2 or -1.5. And the point is 1/2, -1.5. And the other point is -1/2 is +1.5. Yeah, curiosity. This is the minimum point we need. Because actually we have 4 points. 1, 2, 3, 4. See, we have more. Okay, let's do it one more. 4, 3, 4. I select totally arbitrary. F evaluating 4. Well, it's a 4 minus 1 over 4 is 15 over 4. Okay, because 4 times 4 is 16 minus 1, 15 over 4. Okay, decimal is 3.75. Those are the point are 4, 3.75, -4, -3.75. Enough. And that's it. No. I go to Desmos now. I do the graph of this. So far, everyone follow me? Or no? So far?
Yes.
Yes.
And the 7th step I explained in the lecture, guy, it's the same. Let's move on to Desmos. Okay, I open new graphic. A blank. Okay, I want to call, well, okay. I put here, I open one folder. And this is the question 3, no? Question 3. The question 3, the graph is, the function is f of x. What is the problem? Image. Do you see Desmos or no? No?
No.
Okay.
No,
No, Professor.
I switch. No. What? No? No?
Yeah, I see it now.
Yeah, we see it.
Okay. says y equal, or f of x either way, equal x minus 1 over x. Well, this is our graph, but I need to complement this graph. How? For example, we plot the point. What point? The x-intercept, remember, was 1, 0, 1, 0, and black color. The point always in black color, and the corresponding label. Another point was -1, 0. Good, excellent. We have another point, no? Que es, remember, comma, 2, 1.5, 2, 1.5. Okay, excellent. And also take advantage the symmetry is negative 2, negative 1.5. Also, okay, and 1/2, and that's it. Too much. 1/2, 1/2, negative 1/2, negative 1.5. Sorry, negative 1.5. Okay, good. And negative 1/2, negative 1/2, positive 1/2, positive 1.5. Sorry. Enough. 3 points. Don't forget the super important piece of information is the vertical asymptote that was at x equals 0, no? X equals 0. Entonces, always vertical asymptote in black color, dotted line. And the slant asymptote is the line y equal x. Okay, again, black color, dotted line, because it's asymptote. And that's it, guys. This is my question number 3. Let me delete this and this. How do you feel in Desmos? You feel good, no? That's okay? Okay. I want to save this. Save, and there is a review, no? Review. Okay, no, raw review. MAC 1140 review of 4. Test number 1. Save. I condensing this. Yeah, I move on to the next topic. Get the question 4, no? Question 4. Question 4 is similar. Question 4 is another rational function. Okay, question 4. But question 4 we are doing in the whiteboard, and after we move on to this one, no? Guys, everyone follow me. This is weird. This is understandable. Huh?
It's understandable.
Okay, super. Okay, question 4 say do the graph of that function f of x is equal. This is whiteboard, right?
No.
No, it's the Desmos.
Okay. Now
Yes, we see it now.
Let's do it step by step. Step 1 is factor 4. Our function is expressed like that. This is the difference of a square, xx 4 plus or minus. Okay, again, no factors cancel into the no whole. Okay, good. Number 2 is a y and a z. The function de valor es 0. Es obvio que es 0, ¿no? Because 0, you replace x for 0. 0 divided by 0 squared minus 16. Si we have 0 on the top, I don't care what happened in the bottom. The answer is 0, and 0,0 is y and z, and also is x and z. It's the same. The 3 step, que es de x and z, the function equals 0. You know, it's coincident because you take only the top part. And the answer is the same. At that point, it's both. It's x and y and z. Okay, number 4 is vertical asymptote. And vertical asymptote, you take the polynomial in the bottom, is this. Or this, either way. Some people prefer in that way. And solve it like a quadratic equation. It's plus or minus 4. Another people no. Another people prefer the factory form equal to 0. X plus 4 is 0, or x minus 4 is 0. X equal 4 positive, or x equal negative 4. This is negative here, actually. This is positive. X positive 4. Okay, super. In this moment, I'm happy because I am ready to make a roughly sketch of this graphic. Because we have in my hand 0,0, que es x and y and z, and 2 asymptotes, que es 4 and negative 4, ¿no? Entonces es 4 and negative 4. 1, 2, 3, 4. 1, 2, 3, 4. Negative 4, positive 4. 2 asymptotes. Okay, super. Entonces, now the next step is determine the horizontal asymptote or slant asymptote. And remember, to do that, we need to analyze degree. And degree is, let's see. The function that is given at the beginning was x over x squared minus 16. Degree of this polynomial is 1. Degree of this polynomial is 2. And when the degree of the polynomial in the bottom is greater than the degree of the polynomial in the top, yes, we have horizontal asymptote at special case 0. Okay, entonces we have here horizontal asymptote in 0. Okay, so we have vertical asymptote 1, x equal negative 4, vertical asymptote 2, x equal positive 4, horizontal asymptote y equals 0. Okay, now what's the next? Analysis the symmetry. The symmetry is number 6, symmetry. Replace x for negative x, and let's see what happens. And our specific example is, remember, f of x was at the beginning x over x squared minus 16. When you replace x for negative x, you have minus x over minus x squared minus 16. So in the bottom, we have x squared minus 16, identical. On the top, no. It's minus x. Okay, this minus, if you want to see more clear, you put in the front. Here. When you compare this and the original against this, you see it's completely opposite sign, therefore they are odd function. And we take advantage of this. Because in the point, specific point you evaluate, is the seventh topic, seventh step, additional point. Additional points. For example, I take in my paper, for example, 3, because it's in between 0 and 4, I take 5. Automatically, when you take 3 and 5, I know the answer of the negative 3 and negative 5, because I take advantage that my function is odd function. When you evaluate, I want to skip the arithmetic part. Evaluate in 3, the answer is negative 0.428. Therefore, for sure, a negative 3 would be positive 0.428. The same value, but the opposite sign. In 5, the answer is positive 0.5 repeated and negative 5, comma, and negative 0.5 repeat. Okay, we have plenty point to do the graph of this. The information is, we have only one, let me summarize, only one intercept, is 0,0. We have 2 vertical asymptotes, and 4 and negative 4, 1 horizontal and y0, and we have 4 additional points extra. And yet apply the property is odd function. So I go back to Desmos and do the graph. Any questions so far? Everyone follow me or no?
Yeah, I'm following.
Professor,
See, please.
I don't understand where you got negative 0.428.
Well, you evaluate in the original function. So you evaluate in the original function 3 here. Fn3 is equal 3 over 3 squared minus 16, no? This is 3 over 9 minus 16, and this is 3 over negative 7. And when you compare this in your calculator, you get this answer.
Okay, I get it now. Thank you.
Okay, but you don't need to do this, because when you go to Desmos, let me show you how. Okay, in Desmos, okay. Do you see Desmos now? Do you see Desmos now?
Yes.
Yes, okay. You click in the plus, case add element of folder. Folder, question 4. Enter. You put the function, but you put like that. Look, let me show you. Instead of y, you put if you want f of x. F of x equal, and you copy that. Case x over parentheses. Well, not necessarily parentheses, because automatic you put x squared minus 16. Wow, fantastic. I like that. Now we have one point, guess the point 0, 0. Okay, it's the origin, yes, belong to the graph. Another point is the point, okay, the computation was weird. Okay, for example, was open parenthesis 3, 3, something. And something you don't need to compute it. This I'm doing this computation for you, because you put f evaluate 3. Oh, and also why not comma negative 3, no? negative 3 comma f evaluate and negative 3. That's it. And why no? Comma phi comma f evaluate at phi. Where is this point? Oh yeah, there you go. Fantastic. Comma negative phi comma f evaluate at negative phi. In total we have 1, 2, 3, 4, 5 points. One more information we have. Well, we have the vertical asymptote at x equal 4, dotted line, and x equal negative 4. X equal negative 4. Oh, no red, black color, dotted line. And we have also the horizontal case at y equals 0. Y equals 0. Okay, again, black color, dotted line. Wow, fantastic. We finish. And you see clear like water that function is odd function. Because when you change x for negative x, the y change the sign. Any question, guys? No? Crystal clear? Okay. Let's move on to whiteboard now. Here. Over there. You see whiteboard? Yes or no?
Yes.
Answer.
We see whiteboard.
Okay. Number 5, question 6. Do the graph of this. F of x is equal x squared plus x minus 6 divided by x squared minus x minus 2. Okay, step 1. Always, don't forget this, please. Factor 4. You factorization the polynomial on the top. You factorization the polynomial in the bottom is xx, xx. The combination in the top is 3 and 2, no? 3 and 2. Because 3 times 2 is 6, and 3 minus 2 is 1. Positive 3, negative 2. The combination in the bottom is 2 and 1. In this case, negative 2 and positive 1. Everyone follow?
Yes.
Yes.
In this case, yes, we have a hole because you can see a factor x minus 2 is cancelled. So we have a hole at x equal to. Entonces you continue working in the next step using not the original, no, sino the new one, the factor 4, like that, x plus 3 over x plus 1, because it's easier than the original. But under the understanding that this idea exists, that we have a whole and 2. Okay? And so now, in step 2, we find the y-intercept. Y-intercept is f evaluated 0, que es 0 plus 3 divided by 0 plus 1, is 3. Super. At the point 0,3 is our y-intercept. X-intercept is the function equal to 0. It's equivalent to say you take the top part equal to 0. Yeah, I don't care the bottom part. It's not important. It's negative 3. So the point is the point negative 3, 0. So far, I discovered one whole y-intercept and x-intercept. Now, the asymptote. The asymptote, number 4, vertical asymptote. Well, vertical asymptote is the fact to stay alive in the bottom. Okay, by the way, I erase this. Okay, this is x plus 3, x plus 1, no? You take x plus 1 equal to 0. This is the formula, no? For finding the vertical asymptote. It's negative 1. So far, this is a moment in the step number 4 and start doing the sketch. The roughly sketch. After we're doing demo, but no. We have in my hand 0.3, 1, 2, 3, negative 3, 1, 2, 3, and in negative 1, okay, here, negative 3, negative 1, we have vertical asymptote. Vertical asymptote. Only one. Get this. Number 5 is horizontal or slant. And always is the analysis of the degree, no? X plus 3 over x plus 1. You forgot the original. The original is history. We focus in this. Now, degree of this is 1. Degree of this is 1. I know very well that when the degree is the same, yes, we have. Yes, we have. We have horizontal asymptote at y equal 1, que es the division, this coefficient and this coefficient. Okay, 1 divided by 1 is 1. Yes, and 1, we have horizontal asymptote. Horizontal asymptote at y equal 1. And the symmetry, no. We have no symmetry, failed the symmetry. It's over, right? Because the function is too elementary. And when you replace x for negative x is completely different. No opposite sign, no the same, so it's neither. That means that the negative part and the opposite part, you can compute it separately. An additional point, I take totally arbitrary, but I take, for example, I take 4. That point, evaluate the function in 4. And the answer is 1.4. And the point is 4, 1.4. I take negative 6, negative 4, 5, 6. And f and negative 6 is equal 0.6. Is negative 6, 0.6. Okay, I plot everything. Okay, let me see how it look like using my intuition. 4 and 1.4, a little bit here. Therefore, I suppose, can my graph look like that? Asymptote, passing through this point, asymptote. Okay, here is 0.6 positive, is less than 1. Entonces here, asymptote and asymptote. Let's check in this, see everything is okay or not. Okay. Okay. Let's move on to this. Guys, everyone follow me? Everyone understand very well the step? Huh?
Yes.
Okay, super. Let's move into this. Desmos is our friend. Do you like? Okay, what's that? This is another question. Okay, it's question 5. No? Question 5. Right? The function is y equal parentheses. Be careful with this with the parentheses. X squared plus 4 plus x, sorry, minus 6 and the top divided by in the bottom. X squared minus x minus 2. Okay, this is my original graph. Look at that. This is the y-intercept 0,3. Nice, I like that. 0,3. 3. One more, guys. Negative 3,0. Excellent. We have one is a vertical asymptote at x equal negative 3, no. At negative 1. X equal negative 1 is our vertical asymptote. Yes. Black color, dotted line. Okay, one more information we have. Okay, don't remember. When we have the horizontal at y equal 1. Y equal 1. Okay, again, black color dotted line because it's the asymptote. Okay, and the additional point is, remember, bueno, es 4, 1.4, no? Boom. Okay, super. Label for him. Comma, negative 6, comma. So we can compute it using the calculator, or you can compute it using the decimal. So you, instead of put y here, you put f of x or g of x or h of x, one name of the function. In this case, 0.6, 0.6. There you go, perfect. Okay. One more thing I want to emphasize in this example. Well. Let me hear. Okay. Do you see that this is equivalent? Y equal, and the top is x plus 3, put the parentheses, x plus 3 divided by x plus 1, x plus 1. Okay, do you see that the black color curve and the purple color is the same? Look, flashing. What is the only difference between these guys? Well, the difference is in 2. The difference is in 2. Okay, in 2 is, okay, the point 2 is the point, well, another is in 2 comma something, 2 comma 5 over 3, because it's plugging in here, 2 plus 3, 5 over 3, 5 over 3. Oh, this red color point is a hole, and the hole you put like that. Look, you put like a this symbol, like it opens. Okay, how do you know the position for the hole? Well, actually, in my original function is undefined, but in the new one, after you cancel out the hole and stay x plus 3 over x plus 1, you plug it in x equal 2, no? And give me 5 over 3. Fantastic. That's the answer. Okay. Okay. That's one, number 5, no? Okay, let's move on to the number 6. It's inequality. Number 6, 7, Inequality. Okay, super. Let's do it. This is easy part. Do you understand very well the graph? Yes, answer me, yes or no?
Yes, I understand.
No problem.
Yes.
No problem. Okay, let's move on to the number 6 question.
So,
Okay, number 6.
Professor,
Go ahead. Please, go ahead.
then the answer is A on the packet?
I don't know. I don't care this. I suppose que yes, que you're right, mister. Let me see. No way. It's D. Because remember the horizontal is and y equal 1, and also in D you see the hole. Do you see the hole in 2?
Yeah, I see it.
Okay, super. Okay, let's move on to number 6. Number 6 says solve the inequality, polynomial inequality. X to the 4th power less than 9x to the 2nd power. And remember, for solving this polynomial inequality, you manipulate in order to put the 0 in the right hand side.
We can see the whiteboard.
Ah, sorry. Okay. Do you see now?
Yes.
Yes.
Okay, this is number 6. And number 6, remember, you need to manipulate a little bit like that because it's mandatory the right hand side of the inequality should be 0. Must be. Right hand side must be 0. See, though you will have no 0 on the right hand side and the original equation, you need to do that. Now factorization. Factorization, the polynomial in the left hand side. The great common factor is x squared minus 9. Now continue factorization. The effect of a square is x 3 plus or minus. And this is our new inequality in which you focus it to analyze that. Okay? So far it's okay? Entonces now you see, remember, when you have factor that contain even exponent like that, you can partial delete or totally delete. In this case, partial delete because it's no equal. Si es equal here, it's totally delete. Si it's no equal, it's partial delete. So you transform this inequality in this inequality. And don't forget that x is not 0. Okay, this is a compound inequality que incluye another polynomial either because contain 2 factors. And don't forget exclude 0 in the game because 0 here maybe create 0 here and 0 never is less than 0. This is a contradiction. Okay, so this is 100 equivalent to this. Okay. Let's focus in this. Critical value. Critical value is 3 and negative 3. And we are doing the partition of the all real number line. Infinity, negative infinity. Okay, 3 and negative 3. And 0 in the middle. Okay, 0 is the whole. But no, you forgot this temporary. For a moment, you forgot that part. You forgot this part. And the final answer, of course, I consider it. Okay, now you are doing partition here and partition here. You take testing point. Testing point here is negative 4. Testing point here is positive 4. Testing point is 1 or 2 and negative 1. 0 no, because 0 is restriction. The 0 I consider separately. I create a table. Actually, you don't need negative 1. Only one guy in this interval. Actually, we have 2 partitions, 3 testing points. Si es 1 or negative 1, doesn't matter. Okay, entonces testing point in the table -4, 1, and +4. And the factor is x plus 3, x minus 2. And total. -4 is negative here. -4 is negative, the answer is positive. 1 is positive, 1 is negative, the answer is negative. And this is 4 is positive, and 4 is positive, the answer is positive. So we come back again to the original inequality, que es less than 0. Look, less than 0 is equivalent to say negative. The true guy is this. This is the true guy. The only word is 1. The only testing point que pass the test is this, que represent the behavior in this interval. Except the 0, que 0 no. At the beginning I exclude 0. Entonces, paréntesis, 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 paréntesis. If you want to express it, the answer in interval notation is from -3 to 0 union 0 to 3. Negative to 0 or union, either way, this is equivalent to say or, it's the same. Okay, que represent the option B, no? Any question, guys? Do you understand very well everything or no? Yes or no?
I understand.
Excellent. One more, and that's it. Yes. Okay. Number 7 is x to the 4th power minus 21x squared minus 100 greater than 0. The factorization. Okay, in this case, nice. I like that. Right hand side is 0. I don't need to enforce that. Now factorization this triangle. X squared. And the answer is 25 and 4, because 25 times 4 is 100, and 25 minus 4 is 21. And the sign is negative and positive. Okay, super. Now here is another difference of a square, because the factorization is x plus 5, x minus 5. And this is obviously case complex, because the sum of square is prime expression. And by the way, this expression is always positive. It's always positive, never 0. And you totally delete. It doesn't matter if we have no equal sign or not here. Because what is the difference between, look. Let me explain, let me take advantage to explain this idea. Look, what is the difference to x squared alone and x squared plus 4? Well, x squared is a parabola, like that. And maybe it's 0 here. X plus 4, no. It's a parabola, but it's in 4. 1, 2, 3, 4. And this never is negative or 0. Therefore, you totally delete. And my inequality is like that. Super easy. Okay, so the critical value are 5 and -5. And the partition is infinity, negative infinity. 0 in the middle, maybe 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. To say take testing point, maybe 0 is good. Why not? -6 and +6. 3 testing point. Okay. Testing point. -6, 0, and +6. The factor are x plus 5, x minus 5. And total. It's a negative, because -6 plus 5, this is -11, negative together positive. And positive is a good guy, look, it's greater than, positive is a good guy. 0 is positive, 0 is negative, so that's negative. No good. And 6 is positive, and positive is positive. Okay. And then the good guys are this and this. So this is the interval, and this is the interval. Remember, 6 and negative 6 was arbitrary testing point. However, our interval starts in 5 or negative 5. And include 5 and negative 5? No. Because we have no equal sign here. Entonces, this is a strict inequality, que no include the endpoint. We put a parenthesis here and parenthesis here. The solution is from negative infinity, comma negative 5, union 5, comma positive infinity. Like the option D, no? You see that? You see that? Any question, guy? Do you understand very well this inequality? It's a polynomial inequality, non-linear inequality. ¿Sí o no? Yes. Yes or no?
Yeah, we understand.
Yeah.
Super. Now let's move on to number 8. This was number 6, 7, 8. See. A is the using the factor theorem to determine si x minus c is a factor of f of x. So you are doing synthetic division. So you have in number 8, you have a function, a polynomial. Okay, is x cubic plus 2x squared minus 6x plus 8. I need to discover que the factor x plus 4 belong or not to this polynomial. Well, it's easy. You are doing synthetic division. 1, 2, negative 6, 8. Remember the order. This is x to the 0, this is x to the 1, this is x to the second, this is x to the third. The only detail you have to remember is you divide by negative 4, not positive 4. If the factor is x plus 4, the solution is negative 4. Remember, bring down 1, multiplication is negative 4. Combine this guy is negative 2. Multiplication is 8. Combine here is 2. Multiplication is negative 8. And the remainder is 0. When the remainder is 0, that means that the factor x plus 4 belongs to this polynomial. Si the remainder is not 0, entonces the answer is no. Okay? The answer is no. Easy or no? One more. Number 9. Do you follow me?
Yes.
Okay. Suppose this example. Plus 4x squared plus 40x minus 96. I need to testing the factor x minus 12. You are doing synthetic division. Synthetic division is 1, 12, 4, 40, and negative 96. And you put 12 positive. Completely opposite sign to the factor. Bring down 1. Multiplication is 12. This is 24. Multiplication 24 times 12 is 288. Now combine here is 282. Multiplication a big number. When you see the number increasing too far, it's because it doesn't work. Now we combine this guy is 3,544. Multiplication, wow, it's a big number, 42,528. When you subtract this, it's 42,432. This is our remainder. Therefore, the answer is no. These factors do not belong to this polynomial. So the answer is 0, yes. So the answer is no 0, it's no. This is a factor theorem. Factor theorem, yeah. One more, and that's it for today. I'm doing fast. Number 10. Suppose this polynomial f of x is equal to x to the 6th power minus 13, x to the 4th power minus 52, x to the 2nd power plus 64. I need to test in the factor x minus 4. Be careful, be careful, be careful, because the format for the synthetic division, you need to keep in mind that when the one guy is missing, is 0. So this is x to the 0, x to the 1, x to the 2nd, x to the 3rd, x to the 4th, x to the 5th, x to the 6th. This is 1, but this is 0. This is negative 13. This is 0 again, because we have no x to the 3rd power. And this is negative 52. And this is x is missing also. And this is 64. And you divide by 4. Opposite sign of the factor. Bring down 1, 4. 4. 4 times 4 is 16. This is 3 positive. 12. 12. Multiplication is 48. Subtraction is negative 4. Negative 4 and positive 4 is negative 16. It's negative 16, and negative 16 times 4 is negative 64. Remain the 0. Yes! This factor belongs to this. The answer is yes. Got it, guys? Okay, so we continue. I repeat again the idea. We continue. 30. 30, I promise I will send the written test. And this test is due together with the online test and the homework is extra credit, no mandatory. February 1st, que is next Tuesday. Do you understand? Everyone understand very well our schedule? Any problem, any situation, any weird happening for you, you communicate with me. You communicate with me.